You ready? Analyzing data. In lesson 5 in the last unit, we analyzed sets of data relating to quantities, and we used this thing called regression. We looked at the shape by hitting that graph button, which did it as a scatter plot for us. By looking at the shape, we kind of took a guess as to what kind of graph it was. Well, actually, we didn't. I told you what kind of graph it was. But we're going to have to do a bit more of a guess now. Certainly, we should be able to tell whether it's a parabola or whether it's a line. I hope. And we're going to use our technology, our graphing calculators, to do a regression analysis. So here is an example. The concentration in milligrams per liter of medication in a patient's blood is measured as time passes. Here's some data. I don't know what all this means, but I think what I'm going to do is I'm going to go to my graphing calculator software. I'm going to open my stat menu. I'm going to clear anything that I have there. Time almost always is on the x-axis. Those of you in physics know that. So I'm going to put in the first column the times: 0, 1.5, 3, 4.5, 6, 7.5, 9. And then this research person has measured that at these times there was 0, 26.9, 41.2, 47.8, 46, 36.8, and 20.3. And once you've got that typed in, look up, and if you can't remember how to type it in, please let me know, and I will help you. Giancarlo, you want to give him a little elbow? Make sure he's with us? He is? Okay. And then hit the graph. And then graph 1 is usually my default. Boom. Boom. Ah, what was that? I heard someone. What? Okay, if you force me to make a bet right now, I don't think it's an exponential, which would look like this or like this. I don't think it's linear. I think it's a parabola. Okay? Now, we've cooked the data a bit to make it obvious. In real life, with this few points, you couldn't make a good conjecture. You need to get several thousand points, and then it becomes fairly obvious. But do I want you to type several thousand points in? No. So we're kind of saying, here's the idea. It says do a little sketch. So it kind of looks like this, yeah? Certainly, Brianna, I can make a best guess. It says select the best alternative. Now, Brendan said it's a quadratic, a parabola. If it was a constant function, I'd see something like that. I don't. If it was a linear function, I'd either see something like that. Well, the beginning part does, the first half does, but the second half doesn't. Or I'd see something like that. If it was a cubic function, I see something either like this or the other way around going downhill. So, Alyssa, if I had to make a guess, I think it's a quadratic. In fact, we could find the equation. So, regression, this is if you have a TI calculator, how to enter everything. I've showed you how to do it, so we're going to skip. We're going to skip. We're going to skip all the way to example 1. It's the same data. Page 351. So it says this, on a graphing calculator, enter the data into 2 lists. You could ignore blah, 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 blah. Create a scatter plot. Done. And now we're going to press calculate. Yes? Everybody there? Okay, were you on this screen at all? Did you press calculate? Okay, oh, you guys got the older ones. Hang on. Just watch, look up. See, it takes really expensive software to recognize patterns like human beings. This is why those CAPTCHAs that you type in online almost always just take blurry letters that we can figure out, but computers just can't figure out distorted letters. So maybe, don't do this. You might guess that this was a linear graph. It's not. But if you tried to force feed a linear, look, Brendan, at my R value. Remember I said the closer this is to 1, the better? That's a terrible R value. Let me back out of here. Graph, calc. We think this is a quadratic. So can you press F4? And this is what some of you did not understand on the last test that you wrote, that your calculator is giving you the equation. So I need you all to focus if you didn't get over 90% on the last test. What your calculator does when we're doing regression is it gives you the equation Taylor as a template. Here's the template. Y equals ax squared plus bx plus c. Let's write that down. Y equals ax squared, write that down, plus bx plus c. Then, above the template, up here, it's telling you what values work. It's saying A is negative 1.858873. B is 18.7642857. C is 1.2142, that. It's telling you the values. So I had a whole bunch of people on the test that didn't know how to copy out the equation. If it's an exponential, it'll give it to you as an exponential template, fill in the blanks. So here, what's A? I'm going to just go negative 1.86 when I write this. Except, look. What letter do they want me to use instead of X? T squared. What's B? 18.8. See it, Brianna? Plus 18.8. What's next to the B here, Brianna? What's next to the B in my little template right here? An X, but what do they want me to use instead of an X? A T? For time, I'm guessing, yes? Plus, and what's the constant term? 1.21. Oh, and Brianna, while I'm picking on you, what do they want me to use instead of Y? For what word? Concentration. Hey, good concentration on the concentrate. Sorry. Okay, terrible. By the way, is this a good guess? What's your R value? Is your R value on your graphing calculator close to 1? The R squared is 0.99. Okay, that's good data. Now, what else did we do? We said we're going to probably want to analyze this on a graph, so we had to go copy and enter. I think on the black calculators it was something similar but a little bit different, yeah? So now if I go menu graph, I've got my equation sitting there, and I've learned I always have to select it to turn it back on. So part A, there's my equation. Let me pause because I see a bunch of people leaning with their heads. We okay? Sorry? Hang on a second. So Pam, now it says for part B, on the calculator, display the graph of the regression equation over the scatter plot and use the graph to answer the following questions. So we copied the graph so that we didn't have to worry about having to write all those extra decimals. It's done that already. Says there are domain restrictions on the quadratic function determined from the data. Domain is my X values. Clearly the minimum time is 0. So let's go view window, X min, minimum time, 0. Maximum time, I don't know. I'm going to do a bad guess for a reason. All of us, let's put a maximum time of 20, and I'm doing this for a reason. Now let's go up by scale, 2s. Now, what's Y concentration? What's the minimum concentration? 0. Now, I want 0 to actually appear on the graph, so I'm actually going to go -5, just so that the x-axis is a bit higher. And you'll see why in a second. What's the maximum concentration that shows up in my data? What's a nice number bigger than that? 50. Good scale, up by 5s maybe? Yeah. Everybody got that? Now graph this graph. You change the view window, Taylor? Now, here's why I made that terrible guess of 20. Actually, it turns out that's my domain limit right there. Apparently, once time gets past that, all of this has vanished from my blood system. There's no longer any left. Now, the equation doesn't know that. The equation doesn't realize that you can't have a negative concentration. But let's clue in. You can't have a negative concentration in biology. But the math equation doesn't know the biology, Brianna. How can I find, hey, how can I find this thing here? What do we call that thing there? A root. G-solve, root. So those of you that suggested 10, would 10 hours have quite been enough to get all of the data on here? Now, your calculator may have found this root first. You might have to go arrow sideways to get to this root. So see if you can get this root of 10.1595, blah, 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 blah. You got that okay, Pam? Yeah. Yep. Okay. So if I had gone from 0 to 10, would that have captured all the data? No. What do I want to go from? 0 to what? More than 10. 11, you know, what's a nice round? I'm going to go 12 because I like even numbers, and I can go up by 2s for my scale. Also because hours, 12 hours, that's a half day. And again, if you said 11, I'd give you full marks. But as a science nerd, I'm going to say, why wouldn't I go half a day, 12 hours? That makes sense to me too. Okay? So I'm going to go view window, 0 to 12, scale 2. Draw. There is the graph that best matches this data. So part 1 said, determine the domain for this model, for the graph, yes, because the graph does continue going and going. For this model, though, what's the smallest time? 0 all the way up to 10.15, well, all the way up to G-solve root 10.16. That's the difference, Ashley, between a generic graph, which is a parabola, all reals, and, okay, now we're actually talking about legitimate data. And apparently, a little past 10 hours, what are we looking at? Blood sugar concentration? A medication in the blood. After 10 hours, the medication is basically out of this person's blood. So if you were a researcher and you were making a pill bottle here, you'd probably say take 1 tablet every 12 hours or every 8 hours if you wanted there to be some overlap. 12 hours if you wanted it completely out of their system before they took another pill. 8 hours if you were okay with having some overlap, which probably would be what they would write. Okay. What's the range? From 0 to what? How can I find the range, the highest point that it goes? Oh, G-solve max. Apparently, the highest we get is 48.6. And you know what? What units? Milligrams per liter. Okay. I just read that from the data. All right, let's answer part 2. The doctor has decided that the patient needs a second dose of medication when the concentration of blood is less than 10 milligrams per liter. The first dose of medication was given at 9 a.m. At what time should the second dose be given? What's this question asking me to find? Time. Time. Brianna, you okay how we figured that out? Time? Hey, time, is that an X value or a Y value? So that means they must have given me a Y value. What's the Y value that they gave me? 10. So, let's go G solve, arrow sideways. We want to do an X calculation when the Y value is, wait a minute, that's not the one that I want. Because after this, it's above 10. And this question says less than 10. I want, I want this one. Will arrow sideways get you there? Okay, mine did. Does it on the black calculators? You guys really need to try this. So G solve, X calculation. It does get you there too? Okay. Yeah. Now, Logan, we're going to have to interpret this a bit. So, after how many hours? 9.6 hours. So first of all, I'm going to say after 9.6 hours. Now, if we start at 9 a.m., what time is it 9.6 hours later? So if you add 9 hours to 9 a.m., you get 1,800 hours, which is what time? I don't know. Okay. First of all, how do I change 0.6 hours to minutes? Ready, Dom? You're way overcomplicating it. Look up. Just look up. How do I change 1 hour to minutes? 1 hour is 1/60th of a minute. How do I change 2 hours to minutes? 120. How do I change a 1 into a 60 and a 2 into 120? What am I doing? What am I doing? Okay, so times that by 60. I'm just going to do that in my regular math menu. 1.6 times 60. Okay, 36 minutes in. So I'll make a little note here. 36 minutes. So final answer. Yep.
You wrote 0.6 times 6.
Thank you, sir. The time is going to be how many hours in? 6 p.m. In fact, 6:36 p.m. That's 9.6 hours after 9 a.m. A couple more, and then you'll have the rest of class to practice this. Example 2. Hey, we have some data, and it looks like we got productivity on the y-axis, job satisfaction on the x-axis. Boy, some of you must have very little job satisfaction because your productivity is not very, never mind. Okay. Once Brianna's done yawning, you're not the only one. Go to your stat menu, clear what we got. And let's enter this data. This will take a little longer. I got 12 pieces of data, I think. Type this in, please. And then, once you've entered the data, see if you get a scatter plot like the one that they gave you. Now, I heard Giancarlo saying, what? Curves, barely, right? If, you know, with this many points, if you felt it was linear, I'd say it might be. I'm not so sure. I think there's a bit of a curve in it. Let's process of elimination. So do you all get a scatter plot that looks like this? Okay. Is it a parabola? No. Don't think so. Is it an exponential graph that looks like this or like this? Don't think so. Is a logarithmic graph which curved? I don't think so. In fact, the two I'm looking at, it could be linear, or it could be an x cubed that has a inflection point. Which one is the best? We're going to find out. We're going to help us decide by looking at the R value. Actually, it's probably going to tell us that it's, oh, it tells us it's the linear function. I stand back. Let's see. Calc, linear gives me an R value of 0.96. Graph calc. Oh, yeah, I tried fitting it into an X. Oh, 0.98. You know what it is? It's not enough points for the mathematical algorithm to give me a definitive answer. Using regression, you need more points. But since the question is saying we're linear, let's all use a linear, which is just a plain old x to the 1. Get this. Again, Kyle, it's giving me a template. It's telling me my equation is y equals ax plus b. Y equals ax plus b, except Oscar, instead of x, what letter do they want me to use in this question? Look up. Instead of x, what letter do they want me to use in this question? Okay, so it's going to be a J, and instead of y, what letter do they want me to use? P. What's the slope of this graph? 7.91. J plus, what's the y-intercept? 19.9. There's one equation that works. Let's just make a little note. What's the r squared value? 0.92, which is pretty good. Because what we said? The closer it is to what? 1, the better. Part B says, here's what Giancarlo was puzzling. If we go exit, hit the exit button to get to this menu and go graph again. Giancarlo, there's that weird bump there. Maybe it is an x cubed. So let's try doing a cubic regression. And I notice I do get a higher r squared value. Now, what's the cubic template? I don't see it. Well, what's right here, Mackenzie? Right above it. Right above it. Down arrow. Because there's the template. You guys have it on your screen? Okay, on mine it doesn't fit on my screen. Okay, let me just come and look. Pause. Here's my template. Y equals ax cubed plus bx squared plus cx plus d. Except instead of y, Oscar, what letter do they want me to use? Yes, good recovery. So it's going to look like this. P equals, my a value is up here, 0.32. J cubed, then I got to go down arrow to get the rest, minus 6.37. J squared, plus 45.9. J minus 44.2. and nothing gets attached to that. Which one do you think gives you a better representation? I think, Hannah, that little curvy part is suggesting to me this might fit better as an x cubed graph. I think. Also because it's got a higher R value, which we can get in the newer calculators, but not in the older ones. So what are we doing in today's homework? Again, instead of giving you the graph and saying, tell me a data point, it's going to give you some data points. Use it to pick the best graph, find the equation for that graph. Is that okay, Ashley? So what's your homework? Number 1, when it says represent the data, just do a copy of the scatter plot, rough sketch. Okay? And then answer those. 2 is good. Physics kids, who's in my Physics 12 with me? How is distance or height related to time? D equals VIT plus what?
FAT squared.
I'm pretty sure this one's going to end up being a quadratic because it's the squared, but you guys can confirm it. Yeah, 4 is good. Five is good, 6 is good. I think I'm assigning all of it. Yep, 8, 7, and 8. Okay. You got lots of time, 40 minutes. You can also probably get the homework from last class done as well. Also, if you have any missing assignments from last unit, you want to show them to me, now is the time.
Oh,